In this screencast, we will be looking at how you determine the empirical formula of a compound. The empirical formula is the lowest whole number ratio of atoms in a compound. Let's look at some examples. In this table, you can see the difference between a molecular formula and an empirical formula. Notice the empirical formula for hydrogen peroxide is HO, and that's the lowest whole number ratio, whereas the molecular formula, or the actual formula for the compound, is H2O2. Take a minute to look at the rest of these formulas and notice that all of the empirical formulas are the lowest whole number ratio. Sometimes the empirical formula is the same as the molecular formula, like in water. But other times, like in glucose, it's not. The empirical formula is CH2O, and the molecular formula is C6H12O6. Let's take a look at how we calculate the empirical formula. There are 4 steps to follow when you're solving for the empirical formula. The first thing you want to do is change from percent to mass, and then you convert from mass to mole. Divide by the smallest number, and then multiply till whole. If you can remember this little rhyme, it will help you to remember the steps in solving the empirical formula. Make sure that you copy these steps down in your notes because you will be able to use those when we take the quiz at the end of this small unit. A compound is found to contain 50.05% sulfur and 49.95% oxygen by weight. What is the empirical formula of this compound? Our first step is to change from percent to mass. In the problem, we're told that we have 50.05% sulfur. Remember that percent is out of 100, so 50.05% sulfur can just be written as 50.05 grams of sulfur. Likewise, we'll do the same thing for oxygen. 49.95% oxygen can simply be written as 49.95 grams of oxygen, because our percent is out of 100. To convert from grams to moles, we're going to divide by the atomic mass of the element. Sulfur has an atomic mass of 32.1 grams per 1 mole, and oxygen has an atomic mass of 16 grams per 1 mole. 50.05 divided by 32.1 is 1.56. 49.95 divided by 16 is 3.12. The next step is to divide by the smallest number. The smallest number is 1.56, so I'm going to divide both answers by 1.56. 1.56 divided by 1.56 is 1. And 3.12 divided by 1.56 is 2. Now I know what my empirical formula is, because I have 1 sulfur and 2 oxygens. So I write my formula as SO2. Let's look at another sample problem. A compound is found to contain 64.8% carbon, 13.62% hydrogen, and 21.58% oxygen by weight. What is the empirical formula for this compound? Just like in the previous sample problem, we can easily convert from percent to mass by just adding grams instead of the percent sign, since percent is out of 100. So for carbon, we have 64.80 grams. For hydrogen, we have 13.62 grams. And for oxygen, we have 21.58 grams. Step 2 is to convert from grams to moles. So in each case, we're going to divide by the atomic mass for that element. Carbon has an atomic mass of 12 grams, so 64.80 divided by 12 is 5.4. Hydrogen has an atomic mass of 1 gram, so we're going to take 13.62 grams divided by 1 gram, and that will give us 13.62. Oxygen has an atomic mass of 16 grams, so we take 21.58 divided by 16 and we get 1.35. Our next step is to divide by the smallest number. Of our 3 answers, the smallest number is 1.35, so we're going to divide each answer by 1.35. 5.4 divided by 1.35 is 4. 13.62 divided by 1.35 is 10, and 1.35 divided by 1.35 is 1. Now I go back and add these numbers as the subscript for my formula. So my empirical formula is C4 H10O. Now you try some practice problems. A compound is found to contain 31.42% sulfur, 31.35% oxygen, and 37.23% fluorine by weight. What is the empirical formula for this compound? And ammonia reacts with phosphoric acid to form a compound that contains 28.2% nitrogen, 20.8% phosphorus, 8.1% hydrogen, and 42.9% oxygen. Calculate the empirical formula of this compound. In the practice problem sections of your notes, I'd like you to write down the question and then show all work for your answer. You can submit your digital copy of your notes on Schoology or turn your handwritten notes in to Mrs. Benke.